So today what we're going to do is we're going to talk about the properties of logs and natural logs. This is going to help us on our next section when we're going to be solving equations using logs. So let's first define our log. So we're going to say let A be a positive number such that A cannot equal 1, like we said before. And then we're going to say let N be a real number. So if U and V are positive real numbers, then the following are true. So we have three properties. The first property is called the product property. So this tells us that as long as we have a log or a natural log, remember a natural log has a base of E, while a regular log can have any base except for a negative number or 1, which we said right here. As long as these values are being multiplied together, we can actually break them apart using addition. Same thing for natural log over here, can break them apart using addition. This kind of takes us back to our exponent rules. So if we know our exponent rules, when we multiply numbers with the same base, we add our exponents. So that's where the product property really comes into play. The next one is our quotient property. So quotient stands for our division. And so as long as everything inside our parentheses is being divided by, we can separate the numerator and denominator using a subtraction sign. Notice that when this is what's known as condensed form because there's only one log, and this is known as expanded form because there are several logs. All the logs have the same base of A or the same base of E for the natural logs, and numerator is always on top of your denominator. And last but not least, our power property. So when we raise a power to a power, we're multiplying. So in other words, what we can do is we can take that exponent and we are going to bring it in front of our log as if it's being multiplied, right? And so since we've said logs are exponents, these are our numbers being multiplied together. Same thing for natural log U of N. We can bring that N right in front and use their natural log. Okay, so what I want to do is I want to show you a quick little proof of why the product property works, right? So what I'm going to say is this. I'm going to let X equal log A of U, and I'm going to say I'm going to let Y equal log A of V. So if I write that, what I can do is I can kind of change my form. I know that this is true. Then A to the power of X would equal U. And for this equation, I would say A to the power of Y would equal V. All right? So what do we know about our product property? So if our product property tells us that I'm going to be multiplying my U and my V together. Well, really, what does U equal and what does V equal? Well, U equaled A to the power of X, and V equaled A to the power of Y. That's A to the power of Y. What happens when we multiply numbers with the same base? We add our exponents and keep the base. Right? So if since I know that UV is equal to A to the power of X plus Y, then what we can say is our log of A of UV is equal to X plus Y, right? So what I did was I changed my form, right? Here's my base, right? UV right here, exponent, this is what it's equal to. Well, what did I say X was equal to, right? And what did I say my Y was equal to? Well, I wrote a let statement up here. I said let x equal log a of u, right? So log a of uv. So I'm going to replace x with my let statement. So log a of u. And I'm going to replace y with my let statement up there, log a of v. And if we recall, if you look at that, that is our same property for our product, right? So everything comes back to our exponents. Do we know our exponent rules, right? If we do, then these are going to be quite simple. Right? So quotient, product, and power. Please make sure that you have those copied down before you go into our first problems. Okay. So what we're going to do is we are going to expand our logs first. All right, so we'll try a couple together for expanding. We'll try a couple condensing together, and I'll let you try a few on your own. So when we're expanding our logs, the whole idea is to not have anything being multiplied. So I want to get rid of all this multiplication. I don't want to see division, which I don't see here. And I gotta get rid of my exponents. Right, so I gotta get rid of that power of 3. So you might have to take it in several steps. Notice that this log has a base of 4, so all my problems need to have a base of 4. So first things first, I know that they're all being multiplied. So my multiplication rule tells me that if I multiply, I can change all those values to addition. So I'm going to use that property right here. So what does that look like? Log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Right? So again, if I multiply these together, it'd be 5x cubed. And if I multiply that back in, I would be right back here. So I look at here. I notice there's no exponent, so I'm good. There is an exponent on this one, so I am going to use my power property. So I'm going to bring that exponent in front. There's nothing on the y, so we're good. So this answer should read log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. Right? So I've expanded it into 3 logs. I wish there was an answer where I can always say it will be this amount of logs every time. Unfortunately, it's not. So you just want to check to see, do you have any exponents? Are you multiplying? Do you have division or fractions? If you answered yes, then you want to keep going. If you answered no, then you're good to go. All right. So let's try another one. So I see the natural log and a radical 3x minus 5 and then all over 7. So I see division, so it's easy to break those up into 2 problems. So that's the first thing that I'm going to do. Natural log of the radical of 3x minus 5 and then minus the natural log of 7. Now you might be thinking, well, I'm done here. I don't see an exponent. I can't break these 2 up because this is a binomial. It comes together. There was no property that says addition or subtraction. But I want you guys to recall that anytime you have a radical, you can always write it as a fraction. Right? So 2 to the power of 1/2 is the same thing as saying the square root of 2. Right? So I see a radical here. So this is the same thing as saying natural log of 3x minus 5 to the power of 1/2 minus the natural log of 7. So I do actually have an exponent. So I'm going to go ahead and bring that exponent in front. Final answer, 1/2 natural log parentheses 3x minus 5 minus the natural log of 7. We cannot break these apart, right? Because if we do, we'd have to do something with that minus 5. We do not have a property that tells us that we can get rid of that minus 5. So we have to leave it alone. All right. So why don't you go ahead and pause the video, try this one on your own. Okay, so you should have unpaused our video. So what do I notice? I notice it's a fraction. So usually with fractions, it's a safe bet to do that first. So natural log of 3x squared minus the natural log of 4. I have an exponent. I can do one of two things. I can bring it in front first, or I can wait to the end. It doesn't matter. I'm going to bring it in front first, natural log of 3x minus the natural log of 4. Now, we're going to notice that the 3 and the x are being multiplied together, but notice that it both has to have an exponent of 2. So we want to use parentheses. So we're going to say the natural log of 3 plus the natural log of x, close parentheses, minus the natural log of 4. Right? So if I was to distribute, right, 2 times the natural log of 3 would be 2 times the natural log of x. So that is an alternate answer. So you could write it like this: 2 natural log of 3 plus 2 natural log of x minus the natural log of 4. That is another way to write it. I prefer it with the parentheses, but that's just me. All right. So why don't you go ahead, pause that video one more time. Why don't you try our last expanding problem, number 4. Okay, so first thing you should have noticed is there is a fraction. So we are going to go ahead and break that up using a subtraction sign. Okay. Next thing I notice is all of this is being multiplied, so that can all be broken up into using addition signs. I don't want to remove the exponent because notice it's the exponent only on the x, not the 3 or the y. So unlike that third example where I did move the exponent first, I'm going to move that one last. Now for this problem, I need to keep the 2 and the z together, right? So anytime you see more than one thing in your denominator, put those lovely parentheses around. So we will get log of 2 plus log of z, and in parentheses. So that means all of my numerator will be divided by all of my denominator. Last thing, remove that 2 from that exponent. So our final answer should say this: log of 3 plus 2 log of x plus log of y minus parentheses log of 2 plus log of z. All right. Now you can go ahead and you could put parentheses around this if you really want to. So that way parentheses, just like order of operations, tells us that we're going to do that order first. Okay. But it's not necessary since we do read math from left to right. All right. So these were all expanding. Notice that we wrote it out in several logs. So now what we want to do is we want to try to condense. So the whole idea about condensing is to write it as a single log, just like before. So it's almost like going backwards. With fractions at the beginning, I'm indifferent about how you can leave it. You can either leave it as an exponent or you can write it as a radical. Either way is perfectly fine. Okay, so I see that there is an exponent in front of both, so chances are I want to use that first. So this will become log of x to the power of 1/3 plus log of x minus 3, keep those parentheses, to the power of 5. So different powers. I see an addition sign, so that means to multiply. So log of x to the power of 1/3 times x minus 3 to the power of 5. Now, if you want to change that x to the power of 1/3, right, we go back and remember that when we were looking at our second example, when we wrote 2 to the power of 1/2 was equal to a radical of 2, that denominator, right, becomes the type of root that you have. So this is a square root. right? And that numerator is your exponent, so that 2 had an exponent of 1. So I can use that here. So this is a 3. So technically, you could say that this is the cubed root of x times, make sure that that radical stops, x minus 3 to the power of 5. Either one is perfectly fine. Again, you can't distribute in, right, because we'd have to multiply out x minus 3 5 times, and we don't want to do that. All right, let's try another one together. So I have exponent, fantastic. Let's move that first. So this will be the natural log, x minus 4 to the power of 4 minus the natural log of x squared. I don't have to worry about writing it as a radical. I see a subtraction sign, so that tells me I am going to use my quotient property. So I'm going to take my logs and take what my log value is, divide it by my other log value. So notice there's just one fraction, one log. So this should say natural log of x minus 4 to the power of 4 all over x squared. I want to point out right now that where you draw your parentheses and where you draw your fraction lines, log of 2/5 does not equal log of 2 over log of 5, nor does this equal log of 2 over 5. Okay, so these are all different values. All right, if we had a calculator, right, we prove that they're all a little bit different. Lucky for me, I do have a calculator. Right, so if I type in log of 2/5, notice it gives me a negative number. Awesome. So the next one we said log of 2 divided by log of 5. So log of 2, close parentheses, divided by log of 5. Notice it gives you a positive answer. And last but not least, log of 2 divided by 5. So log of 2 divided by 5. Right? So notice that all three of them gave you a different answer. So it does make a difference. So please, please, please make sure that when you see that division sign, you drop the second log and you're just saying that this is your numerator and this is your denominator. So we're just focusing on what's to the right of all of our logs and natural logs. Okay? Why don't you go ahead and pause the video and try this example, number 3. Okay, so I see a set of parentheses. So I don't necessarily want to distribute that 1/5 yet first. I want to multiply these numbers. So 1/5 will stay there. Log base 3, and this will become x times x minus 2. Close that. Now, do I absolutely need the second set of parentheses? No. All right, I can kind of drop those. And my 1/5 is going to become my exponent. So this will look like this, log base 3. Do you want to distribute the x in? Sure, you can, but you don't have to. Now, all of this needs to be raised to the power of 1/5. So my second set of parentheses should go around the x and that other parentheses. Okay, remember the 1/5 can be written as a radical instead. So that will look like this, log base 3. The 5th root of x times x minus 2. So notice that when you write it as a radical, the second set of parentheses can kind of drop out of the way because the radical is going to help you with that. All right. Let's try one more. Let's go ahead, pause that video. All right, so there's a lot of stuff going on right here. So I see set of parentheses, so order of operation tells me I'm going to do that first. So I'm going to write natural log of x plus 2 natural log of y. Now if I wanted to move that exponent, I could. That's fine. 3, and then this will become the natural log. 2 times b, so 2b. Now I have a 3. I can either distribute that positive 3 and keep this as a subtraction sign, or I can distribute as a negative 3, and then I have to remember negative exponents. So either way is perfectly fine. So natural log of x plus the natural log of y squared, right? Because I moved that up. And then this will be minus the natural log of 2b cubed. Let's go ahead and multiply those together. So natural log of x, y squared minus the natural log of 2b cubed. And now we see a division sign. Natural log of x, y squared all over 2b cubed. Again, if you want to distribute that exponent into the 2, make it become an 8, perfectly fine. But you can also leave it exactly the way it is. Okay. So those are your 8 examples. I do have a few more. So what I'm going to do is I'm going to post those right now. And if you want to know the answers, you can just continue watching the video. If you don't and you want a chance to work them off, working them both out or all 4 of them out, you can pause the video, come back to it. All right, so just a few more practice problems. So these are expanding log base 3 of 6x to the power of 4y and log base 5 of 3x squared y square root of z cubed. And then I got some condensing ones. So the first one is negative 2 natural log of x plus 5 natural log of y minus 4/3 natural log of z. And last is 1/5 log base 3 of x plus 5 log base 3 of y minus 2 log base 3 of z minus log base 3 of 5. So I do like this one. If you were going to choose one out of these 4 to try, that would be my choice. So you can go ahead, you can stop the video, come back to it, try these on your own, unless you want to see all of the work right now. Okay. So for this one, they're all being multiplied. So log base 3 of 6 plus log base 3 of x to the power of 4 plus log base 3 of y. Please do not forget the bases. And the 4 comes in front. So log base 3 of 6 plus log base 3, the 4, log base 3 of x plus log base 3 of y. We have completely expanded this problem. Now you might be thinking potentially 6. 6 could be broken up into 2 times 3. Absolutely. But there's no need. Once it's an integer, there's no need to break it up even more. All right, let's try the second one. So I see a division. So log base 5 of 3x squared y minus log base 5. And I'm going to go ahead and write this as a fractional exponent. So 3 halves, right? Because 3 was my original exponent. This is a square root, so the denominator is a 2. Break this apart. Log base 5 of 3 plus log base 5 of x squared plus log base 5 of y minus, I ran out of room, the log base 5 of z to the power of 3 halves. So final answer, I'm going to bring the 2 in front, bring the 3 halves in front. So your answer should read this. Log base 5 of 3 plus 2 log base 5 of x plus log base 5 of y minus 3 halves log base 5 of z. All right. Second to last problem. So let's condense this guy. So negative natural log of 2, that's going to become an exponent. Right? 5 is also going to become an exponent. And 4/3 will also become an exponent. Now, for this one, I'm going to move the negative with it. So so I'm going to make that a plus natural log of z to the power of negative 4/3. So notice that I turned everything into a multiplication, which is fine. So I'm going to multiply all those numbers out. So natural log of x to the power of negative 2, y to the power of 5, z to the power of negative 4/3. Now, if we remember exponents, anything that has a negative in the exponent is going to drop into a denominator. So this problem is going to turn out to be the natural log of y to the power of 5 all over x squared z 4/3. And that's it. I'm going to use that same trick that I used up here for this problem, because I see that I have two negatives and I want to make sure I don't have a fraction over a fraction over a fraction. So first thing I'm going to do is use all my exponents. So log base 3 of x to the power of 1/5 plus log base 3 of y to the power of 5 minus, make that plus log base 3z to the power of negative 2 plus log base 3 5 to the power of negative 1, right? Because there is a negative 1. There's always a 1 in front of your number. So I can always move that value up into your exponent. Now they're all being multiplied. So log base 3 of x to the power of 1/5, y to the power of 5, z to the power of negative 2, 5 to the power of negative 1. Anything that has a negative in the exponent, just like before, going to drop into that denominator. So log base 3 of x to the power of 1/5, y to the power of 5, all over z squared 5. Now, I'm a type of person I would like to write my 5 as a coefficient, so I probably would put it the other way around. So I probably would write it something. I can write it like this. I'll change it up also. For the fifth power, taking the fifth root of x times y to the power of 5, and then all over 5z squared. So again, a couple different ways. I don't really mind as long as you don't put like an addition or subtraction sign on that side. All right, and that is your properties. These are your properties for condensing and expanding logs, right? So please make sure that you keep your product, your quotient, and your power properties handy for natural logs and regular logs.